All right. So I think we should get started. Thank you very much, everybody, for coming, and welcome to Stream 4 on DVCon 2021 to our session, Test-Driven Design and Verification. So one of the things that we want to do today, we want to do this a little different than we do other tutorials are working or our panels working. We're going to do this as a fishbowl conversation. And I'll explain in a minute on what that means, but it is an inclusive session, so you can participate. And we have a lot of great invited guests, but we also want to invite each one of you to participate here. And so what does test-driven design and verification mean? This is being derived from test-driven development, really. So test-driven development is a software development process relying on software being converted to test cases before software is fully developed, and tracking all software development by repeatedly testing the software against all test cases. This is as opposed to software being developed first and test cases created later. So this is what Wikipedia says about test-driven development. Now, I look further and say, what does this really mean? And since I'm Bodo Hoppe, I'm working at IBM, responsible for the System Z processor verification. But then, I looked at an IBM source, and we have a garage, and they have their method, and they're using TDD, and they, with a base concept, they're responding or following the so-called Uncle Bob's rules that say you're not allowed to write any production code unless it is to make a failing unit test pass. You're not allowed to write any more of a unit test that is sufficient to fail, and compilation failures are failures. You're not allowed to write any more production code than is sufficient to pass the one failing unit test. I think this is especially interesting for me as a hardware verification engineer. So what would this mean to our hardware development, to chip development, to IP development, any kind of development? We're going away, from a waterfall to a more agile process, and adopt what would test-driven design and verification mean. Number one is verification engineer and designer will work much closer together. And the idea here is they're co-creating the test case before any Verilog or VHDL or system Verilog, C++ whatsoever is being written according to that feature. And then they together will create a test case that fails on the current environment. And if we look at hardware development, I believe there should be, it should fail. So there should be checking in there, of course, right? There should be stimuli in there, and there should also be coverage events that are being checked to really make sure that we do what we intended. And then the idea then either together or the designer goes off and develops the RTL, verification engineer develops the test bench in whatever language it is, and then they work together until that test case passes. Then we're done. The test case goes into continuous integration. And ideally, if we look at test-driven design and verification, this can serve as our specification. So we want to run this continuously. And if it fails, that means the specification has changed. That's the hypothesis that is subject for the discussion of the next somewhat 50 minutes. So the big question is, can this close the verification gap? Because obviously, when we have the test case written before the code is implemented, of course, we'll be much faster having something running than in random biased verification, or random constraint verification, I should say. And the features will much faster be online for the tests that are being written. So the big question here is also, does this close the verification gap? So the way how we want to do this here is we want to do this as a fishbowl conversation. So we're not live, we're virtual. So we're going to do this a little different. And I hope you're all, all the participants here are ready for some experiments. And I'll explain how this is going to work. A fishbowl conversation, in case you're not familiar with it, is that you have an outer circle. These are people that are sitting outside of the fishbowl, and they're observers. And in the middle, there are people in the fishbowl. The people in the fishbowl are sharing their experiences, their opinions, and there are empty seats in the middle. So people can enter and leave the fishbowl and participate on the conversation. And that's what we want to do here in this session, which I'm really looking forward. I'm a little excited since we've never done this on a conference. So we have some invited guests, which I'm very happy that they joined. So who's in the fishbowl? Who starts here in the fishbowl? And first of all, I want to introduce you to Georg Glaser. He's a digital design and mixed signal system engineer at IMMS. He worked on several scientific and industrial chip designs, and he has a background in mixed signal modeling methodology in his scientific work, and is one of the organizers on the EDA Barcamp, which I still have the shirt here in the background. Then we have Holger Horbach, a colleague of mine. He's a hardware verification engineer at IBM Research and Development in Germany. With more than 15 years of verification experience, he has been exposed to many verification frameworks and methodologies. He's always curious and striving to actively shape the future of verification. Welcome, Holger. And then we have our, Matt Balance, our special guest for joining here from Portland, Oregon. So 2:30 at night, you're stacked up with coffees, as you told us before. And Matt works as a functional verification product engineer at Siemens EDA with a focus on stimulus generation techniques and the Accelera portable test and stimulus language, where probably a lot of people know him from. He has previously worked in the areas of hardware software co-verification, virtual prototyping, and IP encapsulation. So welcome, Matt. And thank you very much for making this unusual time for you. And then we have Philip here. Philip is a full stack hardware software engineer with a keen interest in developing methodologies in free and open source. During the day, he works at low risk on Open Titan, and he's a director at the FOSSI Foundation and the maintainer of the Python-based CocoDB verification framework. And that's actually how we met again later. So welcome, Philip. Thank you very much for joining. And so and we have, last but not least, we have Tudor. Tudor Timiseko is a verification engineer at Infineon Technologies, where he works on security controllers. He's the current lead developer of SVUnit, a unit testing framework for System Verilog, and a proponent of test-driven design in the hardware space. He also writes about verification topics in his blog. So welcome, Tudor. So a lot of great guests. I'm the moderator. As I already said, I'm a verification leader within IBM. And one of the things that I'm very keen on is to, transfer us from a classic waterfall development to enable a user experience driving hardware development from design thinking to feature-based development. And of course, you. So I hope you will join the fishbowl in the time of this session. And I want you guys to, start sharing your experience. It can be the good, the bad, and the ugly. We're always very interested in what you experience in test-driven design and verification and what's related to it, or also share your opinion. And at the end, ask a question. If you just have a question, and you say, well, I don't have really experience and nothing to share, but I really, really want to ask a question, please do so too. So here's some base instructions, and it's going to be quite easy. We got a special allowance as opposed to other sessions. So one of the things that I want to like you to do first is to turn on the gallery view in Zoom as soon as I turn off this. You can already turn it on, but later on the top right button, on the top right, there's like a little widget where you can select to switch to gallery view. Right now it's still screen sharing, so the effect is limited, but as soon as we switch, it's gonna get better. If you want to just watch the fish, turn your camera off. Each one of you has turned the camera off. So the the criteria for now is met. And to join the bowl, so if you want to go into the bowl, you want to share something and or ask a question at any given point in time, please feel free to turn your camera on. You should be aware this is a session that obviously is being recorded. So this is the preferred mode, how you join the fishbowl conversation. As an alternative, you can raise your hand. That's in the bottom of, on the bottom, on the emoticons, you can start saying, I'm gonna raise my hand. Or you just type something in the chat. Here, I wanna say something. But again, we want to do this in an interactive mode and want to include you in it. So we would, love to also see you. And when you're being asked by the moderator, which is myself, so when I see you, you join the fishbowl, I will turn it to you, just in case that many people are coming. I'll try to keep an order. And if you say, I'm done, I don't want to say anything anymore, you just turn your camera off again. So I'll stop the sharing now. Hopefully this is all clear. And we got 50 participants in the Zoom session, which is great. And again, on the top right, you can see the view, and then you can switch to gallery. So you should see, everybody with a camera on are the people that I introduced yourself. If you want to join the conversation later, you're very welcome to do so. So let me start throwing my first question into the bowl here. And I forgot one of the rules. I know we're very excited about all these things and try to talk about everything. Let's try to, when you want to share your experiences, and then try to keep it around a minute, because I know there's a lot of questions and a lot of things around the subject. So we're trying to just keep this focused. So try to keep on to a minute and then pass it on with another question. Or you ask the same question again if you want to look for more opinions. So my first question is, what are your experience with test-driven verification, and how do you think this is going to work? So I'll throw this in. Whoever wants to start, please start.
So maybe I'll take the first step. And I guess I did want to say a couple of words of what I think TDD actually is. So I guess from my perspective, I guess TDD is really the natural next step of the hardware development process. And if you look at what I guess we've been starting over the past few years, what we've really done is the softwareification of the hardware development flow, right? There were, I guess, market needs that forced us to evaluate new processes. We started doing agile development. We started embracing that. We started writing, I guess, what we call feature stories. We started moving to feature-based development, and we started establishing Scrum teams where we've got cross-functional teams that consist of logic designers and verification engineers. And I guess both of these feel responsible for developing a feature. But what does it really mean to deliver this feature? It really means that a logic designer is going to implement a feature, and the verification engineer is going to test that feature, and it has to be regressed. But to understand if a feature has really been fully developed and completed, you have to come up with acceptance criteria. So you have to really understand what it means to complete a feature. And I think this is really where TDD comes into play, because these acceptance criteria, at least from what we've been seeing, is they're usually, they're really fuzzy. You can really evade your way out of things. No one really knows, is this item completely done? So I think this is where TDD really plays a big role, because TDD for me is about formalizing these acceptance criteria. So when we write a feature story, the idea would, I guess from my perspective, would be we spell out individual tests that need to pass for the feature, for the story to actually be completed. And these tests, they should be defined as a collaborative effort. So it's the logic designer and the verification engineer that sit together and define these tests. We want to make sure that the tests are really available early. So I guess newly provided logic can be tested as soon as it's delivered. And I guess there's one other thing I wanted to point out. I think TDD is not a replacement for like a random regression environment or additional testing. I think it's really a precursor, a first step to ensure initial design quality. So I think that's the way I see it. Having that said, is I think we're just starting with that journey. So I guess within my team, we want to start with this. We want to do this, but we don't really have a super big experience. So I think we're eager to pick this up, and we're eager to see how well it's accepted. But we'll see how well it goes. So I'd be really curious to hear from the others here how you guys see this.
Well, I think it's interesting that you mentioned, softwareification of hardware, because I, of course, first experienced TDD from the software side. That's kind of where I got the experience and saw the benefits. I think it does bring some very interesting benefits from starting that conversation between verification testing and the designer quite early, using scenarios as a way to really flesh out what a feature means. And Holger, as you mentioned, there is a little bit of a tension between the activity you do and the early testing of test-driven design verification and the later verification effort that tends to be much more focused and random. And I think one of the challenges with TDD in hardware is, how do we bridge that gap? How do we make it more of a continuum so we're not doing the early efforts and then we still have to do the same job we've always done? How do we make sure that early effort really bridges and helps us with that later effort?
Yeah, so what I'd say is we did some kind of, like, I wouldn't say full the verification driven development like Bodo described, but more like with close interaction between design and the verification. And I guess the problem is, if you try to do the regular style of UVM based test benches in a context like this, you can't keep up. Yeah. So to develop a test bench with self-checking stuff and constrained random, that takes just too long. So either you cut corners and say, what we're going to do is we're going to eyeball it in the beginning and we're going to talk and say, yeah, maybe we develop the stimulus, like a platform to stimulate, and then we discuss kind of what we expect, and then each goes off and builds and integrates often. Or you say, yeah, we built some kind of self-checking tests, like where you do like regular, I give you this, you give me this back, and I expect that, but not like on the fly checks based on monitors and whatever, like what we expect. So I don't expect this kind of like that much reuse from the early effort to the later efforts to be possible because of the productivity gap. Yeah. So unless we end up with some kind of, I don't know, like really primitive style primitives, that we can instantiate and use and say, okay, so this is the same thing we kind of done before, we can really reuse a lot of stuff from there. But I don't think we have the language yet, like the abstract language to do that yet.
Yeah, I mean, one interesting experience I had recently when we did develop a customized CPU design, and there the desire was also to have the specification actually match the real implementation, which is kind of not that uncommon, obviously. But then one part of the implementation, things we implemented, was a instruction set simulator. And this same instruction set simulator would later be used to actually then verify the RTL against this ISS. So what we were able to do is write the operation that the instruction should execute. So effectively, yeah, kind of add this is just add these two numbers together and write that in code that is effectively Python code. So we could put that into the specification and have that as a formal, well, not formalized specification, executable specification for the actual design, and have that even printed out. And use that same code in the instruction set simulation as well. Having this testing, then it already is a predefined framework. So as you said, 2 years, that certainly helps. But then having the ability to write a bit of code and use that as a test and use that together with designers, with specification people to kind of really flesh out the details of what this instruction should do, where the corner cases are, what the exception handling is, and all these kind of tricky details that are easily overlooked. So that actually was a very helpful and productive experience in our case.
I would say with the CPU stuff, you're kind of cheating a bit because that is a domain that's kind of like, I think, very mature. And that does have a more abstract language behind it, you know, like you already mentioned some stuff like instruction, exception, whatever, you know, so that is like a richer domain, which you can say 5 words and mean a lot of stuff in the background, you know, but with bespoke designs, like for like very specialized stuff, you don't even have that kind of abstract language that you can really, you have to develop that first.
Yeah, of course. So in our case, we are developing imager circuits. Or we were developing imager ASICs for the last 2 or 3 tapeouts, and for the digital control and so on, we started writing block level test benches for each and every block, because I, as a designer, so I'm not a real verification engineer, I'm a designer, I want to know that my code works as I intended to do. And I also want to know if I'm working in a team who broke the code, if I did it myself, and when it broke, and so on. So I need some kind of CI, which is obviously known from software. And this means I need a lot of test benches, which should be really simple. If it's just, I want to test if a counter, which counts incoming photons or whatever, works as is expected, pre-synthesis, maybe also post layout, and I want to reuse the test. I want to have a simple way of writing it, and obviously for a block that's that simple, you won't blow up a full UVM test environment. You can do this maybe for larger and more complex blocks, but to get your Lego blocks done and your single components, I'm really a fan of testing all scenarios, doing it in really small steps, and having a regression going, and then handing over to the verification engineer who is testing the integration of the blocks. But I am sure as a designer that they work. So I experienced TDD first the hard way in software when I was writing a Python package for my PhD, and I completely broke the code and try to reconstruct it. And then I just tried to rewrite it using the TDD paradigm. And then I went back to hardware and said, okay, now I want to develop some hardware logic, and I want to test it. I want to see whether it does the correct stuff. And had a look on UVM and so on. And the effort for writing the test benches was large. And then I started to get them as simple as possible, testing directed things. So the constrained random verification can be done afterwards. But I, as a designer, want to be sure that it works as I intended for.
Thanks a lot, everybody. And I just want to, since there were a couple of people joining, if you want to participate in the discussion, and if you want to see this is a fishbowl conversation. So please feel free to just turn on your camera and you will move up in the camera view. I hope this stimulated again to the discussion. And you know, we see Peter joining the conversation. And again, I think the proposal here is if you share your experience or your opinion for about a minute, and then you give a question back to the auditorium to continue going. So Peter, welcome, and please unmute yourself.
Hi, can you hear me?
Yes.
Okay. Yeah, so I'm with Keysight Technologies. I'm an ASIC designer. Also, well, we don't have separate verification engineers, so I do verification as well. I don't have any real experience with test-driven design, but the experience I do have is that it's, so when we make a chip, the specs come from another department in the same company, but they're in a different country, often a different time zone. So the problem we often have is that it's hard to convey the specs clearly. So when something goes wrong, it's usually because we misunderstood the spec, or the spec guys forgot to mention something, or it's always there. And so I'm thinking it could be very interesting to use test-driven design in a way that you can, like when you get a spec, instead of saying, oh yeah, that's the spec, it makes sense, you translate it to a test, and that will trigger all kinds of questions, and you can go back to the spec guys. So, but my main question is, because the intention is, at least in our case, is to do the specification upfront. I suppose that's the case for many people, because we also, based on the specs, we want to decide, can we make it? Are we going to spend money on that, or are we going to do something else? So it needs to happen more or less upfront, except for some details. So my question is, how do you, when you're writing all those tests and there is no design yet to test, what do you do to test your tests? Because in my experience is also that when I find a bug, it's 95% of the time it's in the test code and not in the dot, because the tests are complicated use cases that we want to run. So do you then make a high level prototype in some other language, or how is that done?
Who wants to take that?
Maybe I'm doing this as a designer. So for me, it's a little bit co-development of a test and a block that I'm developing. So, okay, that's not if you're specifying a whole ASIC, but if you want to develop single blocks for a whole ASIC, then we try to get some more abstract view on the ASICs, maybe to have a look on bus transactions. So, for example, the I2C interface modifies the following registers, which are somewhere in the register space, and this triggers whatever, and afterwards I want to get the following data back. And that's quite an abstract view on how this all should work. And afterwards, when we programmed it, we tried to find out where in this design it fails. So it's more or less a dense interaction also between designers and verification engineers, and maybe even some kind of co-development there.
And between which people did you say?
The designer and the verification guys.
Yeah.
So I for example, had really good experience with actually developing the specification as part of the regular iterative development flow as well, and don't have the specification done up front. So there for example, one project we worked on recently, we had a high-level set of rough features, but the details of what exactly had to be implemented and how it had to be implemented was very much open and could actually be iterated on. So I maybe would be interested in also kind of experiences here in the room potentially, where people kind of did move away from this, having the specification completely done in the first step, and then move on to design and verification.
Probably good. Ivo, do you want to take that since you joined the bowl here?
Well, I mean, I can. I wanted to also share my own TDD experiences. Could you real quick rephrase your question?
That was, well, but I guess you start with your experience, but then I would be interested in where people also developed the specification as part of an iterative development flow and didn't have the specification completely ready to start with and then hand it off to RTL design and verification engineers.
In my experience, the specification always changes during the project. So it's, in an ideal world, indeed, we would have the specification up front and go from there, but it changes often, and especially in the first, first step of the design flow, I would say. I don't have really any good answers or tips in this regard, only that sort of the ugly, in the sense that the problems that we ran into in my team, where a specification was not communicated to us, and we would find it only in a higher level of integration, when it's, not too late, but waste of time for everybody. So in my experience, in my team, we have started to use TDD in the last project. sort of what Bodo was describing, and I really like the graph he showed with the verification gap. So we sort of wrote like we basically used our normal checking environment for the checks on hardware, but on the driver side we used a very we just used like a predefined driver to really quickly give the logic team an environment where they can test their new feature or opcode or whatever, while we were still able to reuse all of the checking code that we wrote during that step. That means that in the second iteration, we only had to write a random sim driver, and all the checking was there. Because I heard earlier somebody mentioned, yeah, we should not lose all the time and effort on doing TDD, and then after that, you know, build everything again, but then for random sim. So this is how we overcame that problem. What we did notice is that you really quickly ramp up and have something that works, but after that, there's sort of a time period where you're building and working towards your random regression environment, and then you're sort of like stale for a while. Don't have it. Maybe somebody has a good idea how to close that gap or make that even, you know, make that stale period shorter.
What do you think the biggest effort is going into that gap? Is it checking? Is it developing constraints? What's the kind of what's holding up?
In our experience, it was building a real driver that would then do all the random driving, you know. Yeah. We would typically have multiple interfaces to the same unit, and they all would have to, you know, for example, if you want to drive a certain sequence, you would need to build dependencies in the driver, and that takes a lot of time.
Got it.
Yeah. You know, you could sort of, I'm just thinking out loud here, it would be interesting if sort of this initial static driver could have some form of randomness, you know, where you could at least have some interactions between the interfaces that are already varying latencies between one another. That would already help maybe catch some other initial bugs.
We usually try with these kinds of things is to say not randomize everything, but, you know, just go in the one direction, go in that direction, go in that direction. And you know that, you know, like feature A, feature B, feature C works. And then you start combining, maybe say, this feature works kind of, we kind of know how it should work, but we haven't seen it in the full random regression environment yet. So, but we're working toward it. So we're you know, like we got the directed tests for it passing, and directed test doesn't have to mean like without checking environment or whatever. It just means like the same random test you would run, but with constraints, knobs, and whatever, saying just do that. And once that gets working, you say, okay, we move this to tweaking, adding some more randomness on it, see that works, and so on until you get, you know, like you can activate it in the full environment and say just, you know, like hammer on it. And this way, usually, I mean, like you get the chance to, so you leave all the directed stuff in there as well, because this is a very good way of seeing that the thing still works in isolation. This has also been a good thing that that we noticed, that you then, you know, like you insert a bug as a designer, you immediately see by the failing test case, that's not working because those directed tests are failing, or.
So when I hear this typically requires a lot of architecting of the environment to let get something fluently from very directed to random biased. How do you see designer and verification engineer collaborating in such a model?
Bodo, I think what you're really asking is, I mean, what are really the requirements for successful adaptation or adoption of TDD, right? And I think Peter was just before asking, I mean, how do I test the test? And my thinking is that maybe if we have to test the test, we're already kind of going more into the later phase where we're saying random regressions, complex verification environments. I think TDD tests, they need to be simple, because you want both. I mean, you want to have a quick test, you want to have a designer being able to write the test, and the verification engineer. So I think the hurdle needs to be very low, the entry hurdle, to actually be able to adopt it successfully. I think even there's another aspect, right? I mean, you don't want to go to the designers and the verification guys saying, hey, there's a completely new tool you have to use, and there's a completely new language you have to use. I don't think that's going to work. I think you have to kind of be as least intrusive as you can be. You want to make sure that they can use the existing tools. If I don't know, maybe they're using, I mean, we're using ZenHub, so I would really like to see the TDD solution that we come up with to be completely integrated in ZenHub, so the designers and the verification guys, when they write their stories, they don't have to use a new tool, right? They just write their TDD tests as part of the story, and it's just in there, and somehow automatically it gets converted into a TDD test. Right? I think it needs to be very flexible. We can't really say you have to use this one test case language, and otherwise it won't work. You want to be flexible. You want to be able to maybe have a directed test case language. CocoDB was mentioned. I think that would be awesome. Maybe you want to just say, I have certain coverage events that I want to see hit as part of this, I guess, acceptance criteria. I mean, I think it needs to be a very flexible solution in order to make it possible that people are really adopting this. And I guess hardware developers are stubborn, right? They don't want to have the process kind of get in their way. So we need to make it as easy as possible.
Yeah, and maybe we should also adopt the separation that the software people do between unit tests, which should be as simple as possible and as small as possible, and the integration stuff, which could be more complex and test actual features but not single blocks. And then there we could insert the randomness, and that's also how we are doing it. So the unit test is normally written by me, the designer, and the integration testing is then done by the verification engineer with a fresh look at it. And the overall test scenario, if the mixed signal guys come to it and they say, okay, there's a feature missing, please add here, and then we can just rerun everything and see if we broke something with that. But I think the separation, or to have categories of test cases based on their complexity, is really important, because this also constrains how we could write them.
And this thing you're saying, this reminds me of the, like, designer has their own test bench and they develop on their own test bench, and then you're doing the it depends on what problem you're trying to solve. Yeah, so what problem are you trying to solve? The problem that design understands the spec differently than the verification people, or are you trying to solve the problem that stuff breaks, you know, like, so because I mean, I think the issue is we're talking about two different things. So one is like the designer built the thing that they wanted to build, and the other thing is, did they build the right thing? And usually as a verification engineer, you're concerned with, did they build the thing, you know, that implements the spec, not did they implement that the count that this cycle, this signal comes to cycle later, and then this thing is never like, it's always one hot, and the state transition is not possible, you know?
Yeah, but so that means that the tests that you write to capture the specs, they're going to be the complicated ones, no? Because that's a bit my problem. I mean, the unit testing is always fine here. When the person writes a block, it does what that person thinks a block should do. The problem is always when you glue all the blocks together, they don't do what the customer, who is in some different country, had in mind. And so the stuff I would write up front is not a small unit test. That we could do that, but that's not where the problem is, at least not in our case. It's really those far-fetched use cases that they were counting on, but didn't really tell us. How do we get those early on into a test, and how do we make sure that when the designer plugs in their design, they don't have to start debugging all the stupid one-off errors in the test, but they can really check their design.
One thing, yeah, I would kind of agree with that. And the tests, what kind of the acceptance tests, or does it meet the specification tests, I think can be of very different forms. So we, for example, had a couple cases where we effectively wrote, this was a peripheral, and we wrote software that ran on the main CPU and would just kind of expect certain register reads and writes to happen. So that was effectively the the set of requirements, because these very closely match the requirements that the peripheral had for real world use case. We then expanded that into giving it a set of test vectors. That's something that is, for example, very common in kind of some security algorithms, where you have certain test vectors, interesting corner cases that are just the sets of directed tests. But the other thing that we also did from time to time was just effectively writing asserts together. Assertions that would just test effectively interface behavior that was slightly more complex. That's a language that people in the specification and design and verification world all knew, and that integrates kind of very nicely and on a low level with the existing system Verilog design flow and verification flow that we had. So I guess there are a fair amount of options that you can have for those kind of tests, and it doesn't need to be the full new framework language setup.
I'd like to add, I mean, like TDD is not going to solve we didn't break the requirements for blocks properly to make them fit in the full system problem. Yeah, so this is not solvable by TDD itself.
I think TDD can help to highlight ambiguities, but only one level down, let's say. So if you have a virtual platform, you can highlight, the register level ambiguities. If you're working with a design, you can highlight implementation ambiguities. But it's very difficult to start with an architecture spec and go all the way down to implementation. The gap is too big.
So we have Aurelian joining the conversation here. Mike is all yours.
Hi, Aurelian from AMIC. I have 3 questions, and I would like to hear more concrete examples. I have a current experience with TDD. It's not SV unit. It's something in-house, but it's it looks very much like SV unit. And I can say that it helps if you take the time to write your tests, and then on the long run, you will see that when you do changes in the code and run your continuous integration tests, you will see the test failing, and then you can quickly fix the issue. That's my short experience with TDD. But I think it would be interesting to know how many people here have used TDD. Maybe there is a way to count them. The second thing is, I would be interested in how much time do you consume when you write such a TDD test, such a test. And the third one would be if you can give an example, how did test-driven verification save you along the project?
So let's do I like question number 1. Maybe this is something to the audience. So maybe we'll do a little experiment here, and maybe anyone who used TDD, just write it in the chat and send it there, and we get a feeling on how many did this. So everybody, please just use the chat and type in, I've used it.
They could also raise their hands, Bodo, right?
I was going to say, I think that's a good idea.
Yeah.
Checkbox or something.
Oh, we do see hands going up here a little bit. So it's not that many. There's the one on the picture, and then we got 4, 5, 6 more. As far as
you mean we don't have Philip and Holger raising their hands? I mean, what?
I was saying we're just starting, right? I wouldn't dare saying I've successfully employed it, right? I want to make sure that happens, but.
And I honestly was trying to find a button.
So, and I think this is relevant because there are not many people in here, so it would be nice to steer the discussion so that everyone gets an idea.
Yeah, but so this is our point also while discussing as preparation. So TDD means different things to different people. So for you, it means to develop your verification components using TDD. It doesn't mean to interact with the designers, right? For you, Aurelian, you're muted.
Yeah, for myself, it was just for self-testing the verification code.
Yeah, so that's in any case a totally different beast than when you have to work with other people at the same time. In the sense that, I mean, if you're just working for yourself, you kind of know, you don't have these kinds of like, okay, so I have to explain myself in tests, you know, to another person.
So going to the second and third question that Aurelian asked, I know the third question was how much time it saved you, right? And the second was, I think, anybody wants to share an example of, you know, how could these tests look like and where they were applied? Does anybody want to share that as far as the group here?
I mean, I can share my experience. So for the last project, at the beginning we started to bring up our environment. Basically, the unit my team is working on is we get a certain command, a certain opcode comes in, and we have to do something with it. So at the beginning, we just said, okay, we start with the first opcode we want to do. It's a fetch. Let's figure out a test for fetch and some checking for it. And then we went to the store, and then came all the other commands. So basically, from the beginning of the project we started, we slowly built the library. And at the end of the project, building a new test with checking took maybe an hour. So that was, in the beginning, it's takes some time, but maybe that's just the environment we were using. But as soon as you have built a library, we were even building sequences, for example, to just build one function that would drive a whole fetch sequence and expect everything. And that was very, very useful. And maybe where did it save us? To reproduce, for example, a very specific corner case that you find somewhere, because we had all the driving library was there. So we could, within a day, repro a certain corner case in hardware, which would be very tough, in my opinion, at least with our random biased driver, because it is random, right? And what we did for TDD was more cycle accurate. Like on this cycle, we're going to drive the command. On this cycle, we're going to expect some response. And that behavior is very nice to reproduce corner cases.
Anybody else wants to share an experience? I'm not sure, Stefan, are you still raising your hand because you want to participate, or just because you use TDD? Not, feel free to. Okay, I guess this was the reminder for people to put down their hands. Anybody else wants to share their experience and where they saw positive or not so positive effects from it?
Maybe one addition to what Ivo said, I agree. One of the key things is to build up the library of tests, or kind of test framework or tools or utilities. That could be drivers, that could be monitors, things like that. And yeah, it certainly helps if you start with a design that is reasonably small, kind of implement the easy functionality first. It also allows you to start the drivers and monitors in an easy way, and then grow from there. And that also, I think, slightly addresses what Tudor said initially. In the experience I was sharing before was a very self-contained thing. It's a CPU, and it always does the same things. But kind of over time, you build up these driver monitor components to then allow you to kind of work within your environment that doesn't need to be fully flexible. It's has, in that case, a bus interface, and that's common for very many pieces of IP, that you just kind of reuse that and gain test productivity over time.
So we got two more showing up here. Martin, do you want to unmute yourself?
Yes.
Share your experience.
So my background is mixed signal verification. So I'm dealing with integrating analog and digital blocks together in my job. And there I don't really have experience with test-driven design or verification, because at this point we are really often testing structural things and have to dig into the design to be able to test things. So I think that's very complicated in this domain. But I have another question to the panel. So do you also see some possibility of a risk? Yeah, then in case somebody is writing a test, or verification engineer is writing the test, and imagine the people are not talking with each other, and the design engineer is just trying to make the test screen, so pass all the tests, but is not looking on the actual specification that was there. I mean, in the usual process, yeah, two people are looking on specification, the design engineer and also the verification engineer, and they both try to translate it to the test or the design. But in this case, yeah, there would be only one person that is looking on the specification, that is a verification engineer. Do you see that this is possible to happen, and what can you do against it?
I got something. So have you never seen anybody trying to make a test screen by fixing the test bench up? Or
yeah, I mean, it can happen.
It's the same issue, right? At the end of the day, so. I don't think you can. If you have, it's a cultural thing. If people will just follow what they have and will not think about it, then you can't solve it by TDD, by process like this. Yeah. So.
Yeah, the test is not the specification. It simply illustrates one person's understanding of the specification. Yeah, you always have to beware of fitting to the test.
So
well,
Tobias,
I think it's actually.
Oh, go ahead.
Yeah, I just wanted to say, I mean, I think it actually, using TDD, I think it actually facilitates much closer collaboration between the designer and the verification engineer, because I think they should both be defining the test together when they come up with a feature. So I think that really facilitates a very early collaboration. I think it will also hopefully lead to effects like making the design better suited for verification. So maybe we'll benefit from that, having a design for verification. And ultimately, I guess it should also lead to, I guess, more empowerment of the verification engineer. Just being involved in the process much earlier.
But you're thinking of like design and verification engineers, they sit next to each other and they define it at the same time, right?
Yes, when they define the feature together. Mm-hmm. Yes, I mean, I think it is a collaborative effort.
Mm-hmm. I just wanted to spell this out because maybe this is not what everybody is envisioning in such a process.
Yes. So, Tobias, I think we got time for one more. Do you want to share your experience?
No, I'll try to keep it brief. I don't have any real experience in test-driven development, but what we do, I'm working at a service company that does formal verification of units, of blocks. And I found that unit testing in software is really easy. And I think that has been mentioned a couple of times in this discussion. But also writing the test is really easy, and coming up with simulation-based test benches is sometimes hard. So what we do is, instead of writing test benches for small units, we use formal verification for those small units. And we come up with simple and easy to write properties. And they take away all the burden of writing the test benches, finding the stimuli, because they just either hold or pass, and then you can debug them. And then we do one more thing that maybe gets back to one thing that was mentioned earlier. How do you test the tests? We basically can then build abstract models that we derive the formal properties from that are executable. So we can actually have an abstract simulation and verify that our tests are somewhat reasonable and you don't have any gaps in your tests. Maybe the question to the fishbowl, everybody's talking about testing based on simulation. What do you think about testing based on formal verification?
And that can also work, but you just need the discipline to do restricted formal verification, in my opinion. So a lot of the times you write the one property and then it's going to show you the most annoying corner case that you don't have to fix right at that point. Yeah. So you can just say, let's write the property that just says that under these operations. So the constraining gets difficult if you want to do TDD like this. And by TDD like this, I mean like where you have the design and the verification engineer next to each other.
I think it's the same trade-off that we have with directed and random tests. You can do a very directed style of formal, which I actually find very useful as unit tests, and you kind of avoid what you mentioned, Tudor, of it's unconstrained, you get all the corner cases, but it provides that very nice baseline of expected functionality still working.
Like what Tobias, what you mentioned is, do you do those abstract models based with the designers? So this is, I guess, the question, because otherwise if you do them yourself,
yeah,
and then you just pass them off, then it's still big bang integration at the end. Yeah, so just build it and test it. It does not matter whether this comes up from TDD or whether this comes up from test after the fact.
Yeah,
the abstract models would be a way, as I mentioned before, they were using Python to like formalize the spec and make it executable and get a common ground that you can actually also put as part of your specification or use as part of your specification. That would require some kind of top-down thinking in your design process, which most companies don't do. But I think thinking top-down is mandatory to actually go in an agile flow, right? You need to think first and then develop, not the other way around.
All right, thanks a lot, Tobias. I think we got 4 more minutes left, and I want to give everybody on the panelists here just 30 seconds in the end to say, what do you think can be the biggest benefit of using TDD after hearing everybody's experience? I know this is hard in 30 seconds.
So what I find, it brings a bit more joy to work and life in that case, and because it encourages collaboration and kind of goes away from silo thinking of I'm doing this and you did it wrong and the other way around, and then forces kind of the working together aspect, which is not only good for technical outcome, but it's also good for quality of life and quality of work.
Thank you.
Yeah, so Philip just said what I was going to say. I think it's really about the closer collaboration between the logic designers and the verification engineer. I think that's the biggest benefit that I would see.
For me, it's more like the chance to shape the design as well as a verification engineer, because otherwise it's more like you get this, you have to build. So like the architect, they specified it, and then the designers, they built it, and like we already built it, you have to verify it exactly like this. So if you're involved earlier, and then you're sharing, then we get the chance to say, maybe we don't need to build it exactly like that to still fulfill the requirements.
I think for me, the main point of this whole process is that in this collaboration, we come to a way to quickly ramp up our verification and test environment for a system. Doing this together and having a base for maybe iterations that may follow for updating specs, for adding new features and so on, but coming quickly to the point where we can do this.
I think for me, it's almost taking a positive approach to testing versus a negative, rather than looking for the bugs. You're showing that functionality works, and in some sense, showing it works incrementally as it's being developed. I know on the software side, that's been incredibly beneficial in some senses unsticking even the designer's understanding of how to implement something by having that scenario in place at the beginning.
Right.
Yeah, I also really like the collaboration part, and it makes it actually easy to squash some initial bugs really quickly without looking at a very, very long trace of random sim where all kinds of stuff is happening and you don't really know exactly where it comes from. Just running something in isolation is pretty nice to get quickly some results and feel like that you're like good on the way for this feature.
All right, thank you very much, Ivo. And this brings us to the end of this session. I want to thank you guys very, very much. This was a great experiment, and thank you for everybody for participating. Give a big round of applause. There's some reactions down here. Thank you very much, everybody, and have a good conference. Have a good rest of the conference. Thanks a lot. See you.
Thanks, Bodo, for hosting it.
Yes, thank you.
Bye-bye.
Bodo.
Bye. Thanks.
Bye.